All right, so this is part two. Here's where we left off. If you remember, we were looking at compatible or friendly numbers. Again, we're looking at estimation. We have to be able to solve it in our head. So when two numbers are not very friendly, like 172 divided by 6, that means I can't do it in my head. It doesn't work very nicely. I simply can rewrite it to whatever I want as long as it stays close. I'm going to get a close answer and it's friendly and I can do it in my head. Those are the two things to ask yourself. Is it close to this problem here and can I solve it in my head? So let's go ahead and take some notes on compatible numbers. All right, so let's say I want to solve 9 times 27. That's not very friendly to me. I can't do that in my head super easily. So what I'm going to do is, first of all, I need to remember this rule. Whenever you have one-digit numbers, multiplying and dividing, keep that the same. If you change that to 8 or to 10, you're going to get too far off of your answer. So the 9 is going to stay the same. That's really important. But now instead of times 27, which I can't do in my head, let's change 27 to something more friendly, something I could do. Again, we want it to be as close to 27 as possible, but I can solve mentally. So let's round that up to 30. Now we have something I can do in my head. How we solve 9 times 30 is just do the 9 times 3 is 27, and then you add that 0 because you're doing 9 times 30, not 9 times 3. So we get 270. So again, the first step, one-digit numbers stay the same. Second step, rewrite the problem so that you can solve mentally, but make it easy. Again, it doesn't have to be exact. The focus is that it has to be easy to solve in your head, but it has to be close to the exact answer, and then solve. Let's try one more. Here we have a 3-digit number and a 2-digit number. This is really unfriendly to me. 123 divided by 65. I cannot do that in my head. So I'm going to think, what would be close to both of these numbers that I could come up with a pretty close answer in my head. What stands out to me here is the 12 and the 6. I know 12 divided by 6 is 2. So what if I change this to 120 and this to 60? That I can handle. So these two zeros cancel each other out. I'm going to do 12 divided by 6 equals 2. And so 60 goes into 122 times. And that makes sense if you think backwards. Again, 60 2 times 60 plus 60 does equal 120. So my answer is going to be about 2. So again, I rewrote the problem so that I could solve it in my head. I did not use a calculator. I didn't have to show my work. And my answer is going to be pretty close. And if you want to ever test that out, go ahead and try this on a calculator and see if your answer is close to 2. Again, up here, try this on a calculator and see if your answer is close to 270. Moving on. All right, let's go ahead and do some practice. I'd like you to try these with me. I'll do the first one with you, and then I'd like you to pause the video, try the other three on your own, and then play to check your answers. All right, number 1, we have indicated place value, and they want us to round to the hundreds place. So we're going to underline the hundreds place. We are going to draw those fences. 7 peeks over to its neighbor, which is an 8. So I'm going to round the 7 up to 800. And remember, everything after the fence becomes a 0. 453 is going to peek over. And we have a 5 as our next door neighbor. So we're going to round the 400 up to 500. And everything after the fence becomes 0. So our new problem is 800 plus 500, which equals 1300. All right, go ahead and pause. Try those last 3 problems by yourself, and then play to check your answers when you're ready. All right, let's go ahead and see how you did. We're going to round to the thousands place. So I underline the thousands place, peek over. It's a 9, so 4,000 is going to become 5,000. Everything after the fence, the hundreds place, the tens, and the ones all becomes a 0. 2 is in the thousands place here. We're going to peek over. We have 3 as our next door neighbor, which is less than 5. So 2,000 will remain 2,000. Everything after the fence, the hundreds, tens, and ones, all becomes zeros. Now we're going to go ahead and subtract because now I can do this in my head. 5,000 minus 2,000 is 3,000. And there we go. tens place. So let's underline the tens place. Whoops, peek over. After the next door neighbor is a 6, so we're going to round that up, the tens place up to 6 or 60. After the fence becomes a 0 in the ones place. And then remember, anything to the left stays exactly the same. So 400 stays 400. I rounded this to the tens place. That means I have a number in the tens place. Everything after is a 0. All right, let's do that with 875. Peek over. We have a 7, which is greater than 5, so we're going to round that up to 900. Everything after becomes zeros. All right, tens place. We're going to underline the tens place. Peek over. We're going to round that 10, the 70 up to 80. So 8 in the tens place. Everything after becomes zeros, and everything to the left stays the same. Underline, oops, underline the tens place, the 3. Peek over. We're going to keep that a 3. So in the tens place is a 3. Everything after becomes a 0, and everything to the left stays the same. So now we can go ahead and subtract, and we get 450. Nice job. All right, now we're going to round by the place value, but now it's not indicated. In other words, each problem doesn't tell me what I have to round to. So we're going to do whatever makes sense. If I'm adding 67 plus 14, you're usually going to round to the greatest place value that they both share. So we're going to round to the tens place. So this will become 70 plus 10, which is equal to 80. Let's do one more together. The largest place value that they share is the hundreds. So I can see that I'm going to round this up to 600. I'm going to round this to 300. And my answer is 300. Go ahead and try the rest by yourself and then be ready to check your answers. All right, I'm going to go ahead and just go through each of these and you can see how you did. All right, hopefully you're doing well so far. Again, this one, they share the thousands place. So I'm going to round that to 6,000 minus 4,000, and that equals 2,000. All right, moving on. The last strategy we learned was compatible numbers. So again, I'm going to first, 2 steps before I solve, I'm going to rewrite the problem. 2 things to remember. 1-digit numbers stay the same, and round this to something that's close, but is easy to do in my head. So I'm going to say 60 is close. Divided by 6, yep, I can do that in my head, equals 10. Keep the 1-digit number the same. Close to 51 would be 50. I can do that in my head. 8 times 5 is 40. And then don't forget to add this 0 on as well. So 400. 8 times 5 is 40, so 8 times 50 is 400. Once you pause, try the rest on your own, and then check your answers. All right, here we go. I'm going to round 83 to 80 because 80 divided by 4 I can do in my head easily, which is equal to 20. Here's the problem we had before. 9 times 30. 9 times 3 is 27. The 9 times 30 is 270. Now this one, again, I have to keep the 1-digit number the same. So my question here is, what's close to 49 that is divisible by 6? Well, 6 times 7 is 42. 6 times 8 is 48. So it looks like 48 is the closest number to 49 that is evenly divisible by 6. So that's going to be about 8. And then here again, we'll keep that the same. Round that to 50. It's always nice to round when you're multiplying to a group of 10. And again, we're going to get 400. All right, well, nice job. Let's take a look at one story problem here before we quit. And let's figure out what strategy you want to use and why. Here we go. Sailfish are the fastest fish in the world. They can swim 68 miles an hour. About. Remember, that is your clue that you're going to estimate. how far can a sailfish swim in 3 hours? So I always like to draw a diagram or a picture. This is going to represent 1 hour, 2 hours, 3 hours. Here's how far that sailfish is going. And he can go 68 miles in each of those hours. So I can tell that this is going to be a multiplication problem. So if I was finding the exact answer, I'd be doing 68 times 3, but I don't want an exact answer. I want an estimation. So let's rewrite this problem. The 3 is one digit, stays the same. 68 is close to 70. And then I can multiply and get 210. Don't forget to label about how far, and our unit is miles, so 210 miles. Now, which strategy did we use? Did we use indicated place value? Did it tell us what to round to? Or did we use compatible numbers? Did we decide what numbers could we round to make it friendly and easy? Think about that. All right, you're right. We are going to use, or we did use, compatible numbers. The problem did not tell us what to round to. We just found two numbers that were easy. Um, and that's a great way to solve that problem. So you're going to go ahead now and work on your activities and strategy stretchers and practice problems for this lesson, and then take your checkpoint. So good luck. Remember to be a balloon and to stretch your thinking and enjoy doing it. Good luck.